Okay, so let's go through how to convert a legend back to a protocol. This is the legend over here, and just a reminder that this legend was produced based on working out the final concentrations of various reagents added into the various mixtures as we went through this isolation protocol. So for example, we have a final concentration here of 1.85% SDS, and we have a final concentration here of 1 molar sodium perchlorate. So remember that we started out with a tube of 5 mils of E. coli, and then into those 5 mils we added 0.4 mils of 25% SDS. And so by going through the various calculations, we worked out that in this final volume, which was 5.4 mils, there's a certain concentration of SDS, and the concentration of SDS was such that it was 1.85% weight per volume, which was equal to 1.85 grams per 100 milliliters. Okay, and then on top of this we added a bit of sodium perchlorate, and the perchlorate we added in the lab was essentially 1.3 mils of the perchlorate, and the perchlorate had an initial concentration of 5 molar, which means that in this final volume, which is 6.7 mils, the concentration of the perchlorate was actually 0.97 molar, or that approximates to 1 molar. Okay, so that's how we got these, and then we followed on and said there were other things like had an equal volume of chloroform isoamyl alcohol, and the equal volume was essentially this 6.7, which was existing in this tube before, or right before, this chloroform isoamyl alcohol was added. And then we have these other things later on, and then we have another statement over here that says 2 volumes. And so remember, the 2 volumes is basically whatever is 2 times whatever is remaining inside the tube, and that was of the upper aqueous layer. Then we had the DNA being precipitated and then being dissolved in TE, and the TE was specified as 0.2 mils of TE per 1 mil initial E. coli culture. Now this 0.2 mils, depending on where you've done your lab, in Karsler or in SMB, this may be a bit different. Maybe it's 0.4 mils, but we'll go with 0.2 mils for this particular calculation. Okay, so let's have a think about this first little bit of the legend and use slightly different reagents. And so previously what we used is we used 25% SDS and 5 molar sodium perchlorate. Now imagine that we were in a lab which is in Germany or some other country, or even some other lab in Australia, and different labs have different reagents, different stock reagents, and so instead of 25% SDS, maybe they don't have that, maybe they have 10% SDS instead. So instead of making up a stock of 25%, they made up a stock of 10%, and that's what they use in the lab. And so the question for us now is that, well, we know we need to achieve a 1.85% final concentration of the SDS, but instead of using 25% SDS stock, we need to now use 10% SDS stock. So the question is, how do we get to this final concentration if our stock is slightly different? And the other thing here is, well, we started out initially with 5 mils of this E. coli culture, but say we're again working in a different lab in Germany or something, and this lab doesn't grow up 5 mil cultures, but instead they grow up, say, 10 mil cultures. Okay, so what happens if we have more culture and a different stock concentration of SDS? How do we then add enough SDS to hit this 1.85% final concentration? The way to think about it is, let's draw a picture. So this is our 10 mils of E. coli, and onto this 10 mils we have to then add, say, X mils of the 10% SDS. This means the final volume is going to be 10 plus X milliliters. We know our starting concentration is 10% for the SDS, and we know the final concentration of SDS in this needs to be 1.85%. Okay. Now in this situation, the most pain-free method to do the calculation is to use the C1V1 equals C2V2 formula. Now let's call this left side what we have. Okay, so that could be our stock, and this side is what we want, or what we need. Okay, so the concentration of SDS that we have is 10%. So we'll put 10% on this side, and then we'll times that by the volume, okay, that we have. And the volume that we have corresponds to this volume here, which is the volume that we're going to add into this mixture in order to give us the final concentration of 1.85. So that volume, let's call X milliliters. Okay, and the concentration that we want of SDS is this concentration over here. All right, so we want 1.85%, and the volume that we'll eventually get after we add this SDS is this volume over here. Okay, so we're going to get a volume finally of 10 plus X milliliters. Now it's important when you're working this out to maintain the units on either side. So the volume units are exactly the same, and the concentration units are also exactly the same. Okay, so let's work this algebraically. 10x is equal to 118.5 plus 1.85x. This means that 18.5 is equal to 8.15x, and therefore x is equal to 2.27 essentially milliliters. Okay, so if x is equal to 2.27 milliliters, this means that this is the volume that we need to add. So this will be 2.27 milliliters. Okay, so the next step is to find out how much of the sodium perchlorate we need to add in order to achieve a final concentration of 1 molar. And so here what we're going to do is we already have this 10.27 milliliter solution, and on top of this solution we need to add, now let's say it's Y milliliters of the sodium perchlorate. And in this situation, the other lab we're working in now has the same concentration of the stock, and that concentration of the stock is 5 molar. And so we need to work out now what volume of this 5 molar stock we need to add in order to hit a final concentration of 1 molar in this entire volume, which will essentially be 12, which will be 12.27 milliliters plus Y. Okay, and the concentration in here needs to be 1 molar. So again, we can use the C1V1 equals C2V2 formula, and let's say this is what we have, and this is what we want or need. So what we have, the concentration of the stock that we have is 5 molar. So let's write that, 5 molar times, and the volume of stock that we're going to be adding is Y milliliters. So that's Y milliliters equals the concentration that we're going to hit, the concentration that we need to hit, which is 1, okay, well, approximately 0.97. So that's, let's just use 1 molar to make the calculation easy for us. And over here, the volume that we're going to have after we add what we want is going to be 12.27 plus Y milliliters. And again, you notice that the units for the volume and the units for the concentration are all the same. It's important to match these. Okay, so let's do a bit of algebra. This will be 5y is equal to 12.27 plus y, which means that 4y is 12.27, which means that y is equal to 3.068 approximately. Okay, so this means that now using these new stocks, okay, so using the 10% STS stock, using the same stock concentration of the sodium perchlorate, this Y essentially means that we have to add 3.068 milliliters in order to get this final concentration of 1 molar. So this means that our final volume is going to be 12.27 plus 3.068. It's going to approximately be 15.34 milliliters. Okay, so what we have so far now is a total volume of 15.4 milliliters, and that's sitting here in our tube, which has the perchlorate, the STS, as well as the E. coli solution inside it. And so the next thing that the legend tells us to do is that to extract the solution with an equal volume of chloroform isoamyl alcohol. Now, this equal volume means whatever volume is currently present inside the tube, and that is 15.34 milliliters. Now the question is, well, how do we express this in a protocol? Well, we can express this in a protocol as literally an equal volume. Okay, there's no need to change this particular statement because an equal volume just tells the scientist use whatever volume is already in there and add that same volume. Okay. If you want to be specific, you can specify in this particular situation, you can specify that the equal volume means it's 15.34 mils. But if you're just writing a general protocol, you don't really need to state anything other than it's an equal volume, because a scientist reading your protocol will understand what this means. Okay, so the next part of the legend talks about inverting or mixing the tube for 10 minutes and then centrifuging this. So again, none of this will change based on your volumes or your different stock concentrations. It's important to see here that this 4,500 RPM is there because any centrifuge that a different scientist uses, for example in Germany, will need to be set to this particular rotational speed in order to achieve this centrifugation goal. The next little bit talks about removing the upper aqueous layer, and again this doesn't need to be changed. After your centrifugation you may get your layers, and the scientist knows to remove that upper aqueous layer, whatever the volume is. And then it says 2 volumes of the 100% ethanol are added on top. And again, there's no need to change that because whatever this volume is, let's call this W milliliters, the scientist knows to add 2 times W milliliters of the ethanol on top of that. Okay, and then we can say over here, DNA collected, precipitate was washed and dissolved in TE. And the important thing here about TE is that we used, well, the legend says that we used 0.2 mils of TE per mil of the initial E. coli culture. So if you recall, in this particular situation, this particular lab had 10 mil cultures of E. coli. So if we're saying that we need 0.2 mils of TE per 1 mil of E. coli culture, this means that in 10 mils of E. coli culture, we need, so 1 times 10 is equal to 10, therefore 0.2 times 10 is equal to 2 mils. Okay, so we actually need to now, if we're writing a protocol for this 10 mils of culture, we need to say you need to dissolve the DNA in 2 mils of TE. Okay, so that's essentially it, converting a legend to a protocol. The main things to watch out for are the concentrations. You need to hit the original concentrations, and also anything that has anything that's dependent on different volumes you need to account for as well, for example the TE. Sometimes you don't need to change things. For example, if something is specifying 2 volumes, then the scientist knows what those 2 volumes or 1 volume means, and so there's no need to adjust that in the revised protocol.